first video is about what is water, because in this unit this is all about dissolving your solid into water. And as a lot of times that we know, we all have seen the formula for water as being H2O. But what exactly when you dissolve salt into water, right? Like when we talk about something like solid salt, such as your NaCl, your table salt, we know that when this starts off, it's a solid, right? You have little solid crystals. But what happens when you put this into a beaker of water? How come after stirring this, all of the NaCl sort of disappears? So in order to look at that, we have to look at the structure of water. And when we look at the structure of water, it actually gives you a really good idea on, oh, that's the reason why that water is such a good solvent to dissolve ionic solids. So when we look at the structure of water, we see that there's 2 hydrogens for every 1 oxygen. And when it's bonded, it actually has a bond angle about 104.5 degrees. And the key thing about water is that you have to look at the electronegativity value of water. You're going to see that oxygen, excuse me, oxygen is actually a little bit more electronegative. That means that it draws the electrons closer to oxygen than hydrogen. So what that means is that if we were to draw like the electron cloud of this, there is more oxygen around, more electrons around oxygen than around hydrogen. So because there is more electrons around oxygen, that actually makes it a sort of a negative side, and which leaves hydrogen to have more of a positive side. So because of this reason, this makes your water sort of have this polarity. So what happens when you dissolve the salt into water? Well, when you look at this beaker, you know that if I were to draw a lot of water molecules, you have your H's that has slightly positive and oxygen slightly negative. And when NaCl comes into the water, it actually will get dissociated. That means that it will break apart into its separate ions, right? So when NaCl gets into or dissolves into solution, you actually have your Na plus, because that's the ion, and separates into your Cl minus. And both of these are what we call in aqueous. That means that they're in solution. So whenever you see AQ, this is aqueous. That means that it is dissolved in water solution. So this is in solution. And then once it gets in the water, you notice that this water molecule has a positive end. So it's going to naturally attract and draw in your Cl. So all of your positive ends of your water will sort of hover, surrounds the negative chlorine, because opposites attract. I'm just going to fill the rest in here. And then so what happens to the Na? So let's blow this up a little bit more. So what happens to the positive Na ion is that, well, the negative oxygen is going to surround it. So this is your negative oxygen. It's going to surround it. That's what happens when you dissolve ionic salts. I should put another hydrogen here. That's what happens, because all the negative will surround the positive, all the positive will surround your negative Cl minus. So this is your process of solvation, is that this ionic solid, when it goes into solution in aqueous form and dissolves in water, it gets dissociated into your different ions. And that's what makes water very unique. And it's because of this electronegativity value of oxygen drawing more negative or electrons to itself. So that's a unique way of looking at water. So hopefully that video has helped you with that. Thanks for watching.